I would now like to, if there are no questions at this stage on the technical aspects and on the program for the day, which I don't see, then it is my great pleasure and delight to introduce our keynote speaker of the day, Professor Francois Engelbrecht of the University of the Witwatersrand in Johannesburg, one of the most distinguished international climate change experts, and we are very delighted to have him with us this morning. Francois is a distinguished professor of climatology at the Global Change Institute of Wits University in South Africa. He specializes in the projection of future climate change in Africa, and he also served as an invited lead author of the Intergovernmental Panel on Climate Change's special report on global warming of 1.5 degrees, published in 2018. And he is currently also an invited lead author of Working Group 1 of Assessment Report 6 of the International Panel. His research is not only on global climate change issues, but he connects the global to the local. His publications in that respect include, for example, a framework for assessing the risks and impacts of rural access roads to a changing climate, so very much a local topic also. And he has also worked on COVID-19 related issues recently. The publication in that respect is Tests for COVID-19 Seasonality and the Risk of Second Waves. Francois, we're so happy to have you, and I would say the floor is yours. You have about 25 minutes.
Many thanks, Philip, for these very kind words of introduction. I am going to share my screen and then I'll start with the presentation. So let me just choose here the share screen option. Okay, so I trust we are in business. Philip, maybe you can just, yeah, thank you. I can see you.
Yes, we are. Yes, we are.
Thank you. Thanks again for the kind words, Philip. And I would also like to thank Juliana and Malan for my original invitation to participate in this event. It's certainly a great privilege to present to this group of colleagues today. I'm going to do my very best to provide a quick but comprehensive background on the challenges we are facing in Africa, but also globally, when it comes to the future impacts of climate change. And specifically, I will also talk about how important it is to still do our very best to present the most dangerous impacts from climate change of occurring. And of course, I will be referring to the Paris Agreement on climate change within that context. So let me start to provide an overview of the current state of climate and climate change in Africa. I would first like to point out the terrible event that happened last year in March in Mozambique. On the 14th of March, tropical cyclone Indai made landfall at Beira, almost exactly at the city of Beira. And I think too few people know that this is the single worst flood disaster that has ever occurred, at least as far as the historical record is concerned, in Southern Africa. More than 1,000 people lost their lives in this storm. The last time that more than 1,000 people lost their lives in this part of the world, that was back in 1892, when a tropical cyclone made landfall over Mauritius, and then more than 1,500 people died. But it it is, of course, a startling thought to think that in this day and age, with all our technologies and in the modern world, more than 1,000 people can still lose their lives in a single storm event. This storm left in its wake an inland lake to the west of Beira, as you can see by the red shades in that slide. So, of course, widespread flooding occurred because of the heavy rainfall caused by the tropical cyclone, and in Beira also by the storm surge itself. The storm surge is effectively a wall of water that moves from the ocean into the land area due to the high winds generated by these storms. So I'm presenting to you these slides within a climate change context because when the IPCC published its special report on global warming on 1.5 degrees Celsius back in 2018, it showed quite clearly that nowadays when tropical cyclones occur, they cause 10 to 15% more rainfall than in the past. And there is also evidence that a number of intense tropical cyclones, in America, these would be called the Category 4 and Category 5 hurricanes. These types of tropical cyclones are occurring more frequently across the world as a consequence of climate change. And of course, our own region here in Southern Africa and the Southwest Indian Ocean is no exception. So as we'll move on, I will talk more and more about how climate change is changing the occurrence of extreme events across the planet. So 2019, the year during which this storm made landfall, was in fact the second warmest year ever recorded by humans. So reliable measurements go back to more or less 1850. 19 of the 20 warmest years ever recorded by humans occurred in the last 20 years. The last 5 years are the warmest 5 years on record. So I'm just mentioning these statistics to demonstrate to everybody that we are certainly living in the days of global warming. And climate science is very clear that we as humans, we are responsible for that warming. 2019, you can see, we experienced the warmest year in recorded history across almost the entire region. So the entire Angola, Namibia, Botswana, Western South Africa, Tanzania, Northern Mozambique, the Indian Ocean where the cyclone formed. You can see all those regions in 2019 experienced the warmest year in the historical record. So tropical cyclones and intense storms, that is one type of extreme event. But I would like to also talk as a bit more background about what happened during the summer of the years 2015 and 16 in Southern Africa. So as you can see in that slide, once again, the dark red regions indicate those parts of the world where the all-time temperature records were broken. And you can see that in that summer season, the entire Southern Africa experienced the warmest summer in recorded history. That remains the warmest summer Southern Africa has ever recorded. And the year 2016 was also the warmest year in the historical record. So 2015, in fact, was the first year when the global average surface temperature was 1 degree Celsius higher than the pre-industrial temperature, the so-called natural temperature of Earth. So at the time, 2015 was the warmest year globally ever detected by humans. 2016 was warmer than that. And since then, 2019 came in as the second warmest year on record. And right now, colleagues, it looks as if 2020 may be the warmest year, even warmer than 2016, but possibly the second warmest. So in this year of 2015-16, such an exceptionally warm year, what happened in Southern Africa? Well, firstly, we saw during the summer of 2015-16, the strongest El Nino event ever recorded by humans. So El Nino refers to the warming of the tropical Pacific Ocean. And the Southern Africans in this call, they may well know about what typically happens in our region during El Nino events, namely that we experience widespread drought. That is a photograph I took close to Kroonstad in the Free State province of South Africa. That was back in that was in December 2015. You can see a big dust storm. And during that very dry summer, we saw more dust storms than ever before over the central interior of our region, of our country, South Africa. And the maize crop in that year was also about 40% less compared to the previous summer. Further to the east, we had a terrible drought in Kruger Park. Many of you may remember about the culling that had to take place in Kruger Park because of widely depleted grazing, as you can see in that photograph, and also because of many of the rivers running dry. So that was a typical El Nino type drought. But the IPCC report back in 2018 also pointed out that if we would continue to warm the planet until the point where we reach 1.5 degrees Celsius of global warming, these types of droughts will occur far more frequently in Southern Africa. And there's also the possibility that a very strong El Nino events will occur more frequently. And then, of course, extreme weather events are not limited to the Southern African region. There's evidence that these types of events are increasing across the world. There are so many examples, but let me just stick to one of the most prominent changes we can currently witness on the planet, namely the melting of the world's big ice sheets and glaciers across the world. For example, back in 2017, we had a big iceberg breaking loose from the Larsen Sea ice shelf. That single iceberg had an area of 5,800 square kilometers, as big as 1/3 of Kruger Park, to put that into perspective for the Southern Africans in the call. A massive single iceberg. But right now, if you've been looking at the mainstream media outlets over the last few weeks, there is evidence of the Greenland ice sheet melting faster than ever before. And in terms of this part of the talk, this is where maybe I want to conclude this overview of extreme events. I want to point out that the reason why we have the Paris Agreement on climate change is to prevent the most dangerous impacts of climate change from occurring. Now, climate science originally said that in order to prevent, for example, the irreversible melting of the Greenland ice sheet, we need to keep the global temperature increase to below 2 degrees Celsius. And that is the main reason why the Paris Agreement is currently stating that the countries of the world should strive to restrict global warming to 2 degrees Celsius. But more recent science has indicated that that level should rather be 1.5 degrees Celsius. The latest evidence is that some of these most dangerous events, like the irreversible melting of the Greenland ice sheet and the West Antarctic ice sheet, may in fact occur at levels of global warming between 1.5 and 2 degrees Celsius. We are extremely close to exceeding those levels. I will get to that very soon in the talk. But should that happen, it will commit, of course, future generations to catastrophic sea level rise that will displace hundreds of millions of people from where they are currently living. I'll get back to that. So I've given a brief overview of different types of extreme events, focusing on the Southern African region. Now I would like to systematically talk about climate change, gradual and sometimes rapid changes in the world's climate system. I'm going to talk about mitigation. So how can we slow down the process of global warming? Can we still turn it around? I'll speak about that. And then I'm going to conclude with giving some projections of future climate change, specifically for the Southern African region. So let's start to review the evidence. The first thing I want to point out is that climate change is already occurring, as I think everybody knows. It's not only something of the far future, as some politicians sometimes try to still tell us. It's happening already. If we look at what has happened in Southern Africa over the last 5 decades, we can only call what we've observed alarming. So this slide shows the rate at which temperatures are currently increasing in Southern Africa. So the scale here on the y-axis shows the rate of temperature increase in degrees Celsius per century. Now, as I've mentioned, by the year 2015, the world has warmed by about 1 degree Celsius on the average, but that includes all the world oceans. The land areas of the world are warming faster, and Southern Africa is no exception. You can see here that in Southern Africa, the rate of warming over the last 5 decades has been in the order of 2 degrees Celsius per century, or even more. In northern Botswana and southern Zambia, we observed the highest rate of temperature increase of all the southern hemisphere continents of South America, Southern Africa, and Australia. Here temperatures are currently rising at more than 3 degrees Celsius per century. Okay, this is an important, extremely important thing to be aware of. Even if the world is successful and constrains global warming to 2 degrees Celsius through the Paris Agreement, we are still looking at temperature increases in the order of 4 degrees Celsius in our own region. And that will have a range of impacts. If the world is unsuccessful in implementing the Paris Agreement, then of course, temperature increases in Southern Africa will be even more severe. What is causing climate change? The evidence is overwhelming that it is us through the emission of carbon dioxide concentrations into the atmosphere. We have built the world's economy on the fossil fuels, coal and oil. When we burn these fossil fuels, we emit carbon dioxide into the atmosphere. And right now, carbon dioxide concentrations in the atmosphere are increasing according to this thick black line you can see in the graph. It's called a low mitigation future. This line shows how carbon dioxide concentrations will continue to rise in the atmosphere if we continue to generate energy mostly through oil and coal. Now, if we follow a Paris Agreement type future, you can see that carbon dioxide concentrations will still increase until the mid-century, but then it will start to gradually decrease as we also manage to remove some of that carbon dioxide from the atmosphere through some new technologies. Right now, humanity is on this pathway. It can still choose to follow this pathway. If we follow a low mitigation future, you can see that by the end of the century, climate models are projecting that the global temperature increase will be something between 3.2 and 5.4 degrees Celsius. Okay, it will be worse region. If we implement this type of strong mitigation scenario and we change the world and we try to rather generate energy through renewable sources, then we may still be able to restrict global warming to 2 degrees Celsius, and we may prevent the most dangerous impacts of climate change. The IPCC special report published in 2018 stated that at the rate that we are currently emitting greenhouse gases into the atmosphere, we may exceed that critical warming level of 1.5 degrees Celsius as early as the year 2030. Okay, so immediate action is needed. the report specified what we need to do to restrict global warming to 1.5 degrees Celsius. It is a tremendous challenge. We need to restrict global emissions of carbon dioxide. We need to reduce emissions with 45% by 2030 with respect to the 2010 levels. And then we must continue, and by 2050, we must achieve a world where there are no further emissions of carbon dioxide into the atmosphere. We call that net zero emissions. If we want to give up, if we think we cannot make this threshold of restricting global warming to 1.5 degrees Celsius, then we must still, if we want to keep the temperature increase to below 2 degrees Celsius, we just win 20 years. Then we must still achieve net zero emissions by 2070. It's an immense challenge. In this year of COVID-19, it is estimated that global carbon dioxide emissions will be about 10% less than they usually are, because of this catastrophe that has happened to us. This is a far more stringent challenge. A permanent reduction of 45% in emissions must be achieved by 2030. After that, it must continue to decrease until net zero emissions. Just to put into perspective what a tremendous challenge this is for humanity. The rest of the talk will demonstrate what will happen if we fail to restrict global warming to 1.5 degrees Celsius and failing that to 2 degrees Celsius. All the remaining slides are about Southern Africa except this one, and two other slides that I just want to show about global climate change, politics, and the mitigation effort. So globally, I would just like to point out that climate scientists are summarizing the main concerns about climate change into 5 categories. I'll just speak about 2 very briefly. Large-scale singular events. These are really bad things that can happen in science language. But here we are referring to the melting of the world's big ice sheets. The latest evidence, everybody, is that some scientists now think that we have already made the Greenland ice sheet unstable in an irreversible way. That will commit future generations to sea level increase of about 6 meters. In our own lifetimes, it may be as bad as 1 to 2 meters. The rough guideline is that every meter of sea level rise displaces more or less 100 million people from where they currently live, okay, for the current world population. This is a tremendous threat we will be facing over the next few decades, the continuous rise in sea level. Unique and threatened systems. We are irreversibly causing damage to our beautiful planet. The IPCC special report indicated that under 2 degrees of global warming, we will lose all of the world's warm coral reefs. So that precious ecosystem will be gone. And even at 1.5 degrees Celsius of global warming, we will lose 90% of the world's warm coral reefs. Nevertheless, when the IPCC presented this report to the world back in 2018, it had the slogan, "Reasons for Hope." Okay, this is a picture I took in Incheon in South Korea just when the conference ended. Because the IPCC still pointed out that humanity can still avoid these critical thresholds if action is taken immediately. What has happened since? Well, one important drawback for the climate change mitigation effort is that the United States has announced that they will withdraw from the Paris Agreement. And that agreement will come in force in November this year. Why is that so important? Well, the United States is responsible historically for about 40% of the enhanced greenhouse effect. So 40% of the global warming can be attributed to emissions originating in the United States, all the way back to the Industrial Revolution. Today, North America is still responsible for about 19% of the emissions. In the European Union, it's about 18%. Across the countries from Asia, about 52%. And Africa today still only contributes about 3% of emissions. The historical responsibility of Africa to carbon dioxide in the atmosphere is only about 1%, okay, to the additional carbon dioxide. That brings us to an entirely different topic, and I'm sure Philip is checking the time. I can't speak to it in too much detail, but there's the concept of climate justice. Who's really responsible for this problem? But I need to move on. Let me just say that without the United States and China collaborating, the problem of global warming cannot be solved. If the two superpowers are not mitigating climate change, the world is lost in the sense that we will exceed those critical thresholds of global warming. Another, what I think is a very positive development since 2018 was the enhanced awareness of the youth when it comes to environmental issues. And we've seen, for example, the youth climate strikes and the school strikes across the world. This is also the case in South Africa. So in South Africa, we are observing an increased awareness about environmental issues at among the students at the South African universities. I can also report something very positive. The South African government, unlike many other governments, is quite mainstream in terms of its climate change, policy. And for example, last year at the United Nations Climate Change Summit, President Ramaphosa's submission announced effectively a very ambitious $11 billion just transition climate transaction, which is aimed at systematically and in a just way replacing South Africa's dependence on coal as the main source of energy by alternative forms of energy. So the mitigation effort is playing out in front of our eyes, and of course there are many forces at play. Who can predict what will happen? What we as climate change scientists do, and I'm going to conclude with this, we use the science of climate. So we use the physics, our knowledge of physics and chemistry and mathematics to generate projections of future climate change. We do not decide what will happen politically or in terms of the economy of the world. We look at low mitigation futures where we do very little to mitigate climate change, and we look at Paris Agreement type futures in terms of emissions. And our job as climate scientists is to investigate how the climate system will respond to these forces. So let me give you some examples. Firstly, globally, this results from the IPCC's Assessment Report 5. The main message is, as we are meeting in this webinar today, the world still has a choice. We can either continue on our current pathway and we will experience drastic global warming. You can see in these types of scenarios, the temperature increases in southern Africa are in the order of 5 degrees Celsius or more by the end of the century. Or we can head towards this type of world where we can restrict temperature increases in southern Africa to less than 3 degrees Celsius and globally to 1.5 to 2 degrees Celsius. So right now, the science tells us we still have a choice. What is going to happen specifically over southern Africa? I'm going to play an animation. It will take about 1 minute. We are going to look at changing temperature patterns in Africa from 1971 until the end of the century. So what you can see in the blue colors, those are years that were abnormally cool, and the yellow colors indicate years that were abnormally warm. That is with respect to the average climate of 1971 to the year 2000. You can see as we reach the 1990s, and for a start you can look at this animation at the bottom of the slide, which is a low mitigation future. You can see how our region, Southern Africa, was already getting warmer and warmer in the 1990s and the 2000s because of the greenhouse effect that is strengthening. And as we move into the future, which is very soon in this animation, you will see how the Southern African region warms rapidly, faster than tropical Africa, faster than the surrounding oceans, as we've already seen in the observations. And now you can see red colors appearing in the low mitigation future. Those are years that are 3 degrees Celsius warmer than what they are supposed to be. And you'll see that those types of years are already commonly occurring only in the 2040s, which is just around the corner. And then as we move into the second half of the century, you can see how Southern Africa is transformed into a region unknown to us. Drastic increases in temperature. The temperature increases approach 6 degrees Celsius towards the end of the century in this low mitigation future. And of course, those will be accompanied by more heat waves, more days with a high fire danger, and as I will show soon, also with more frequent droughts. If we can follow a stronger mitigation future, like in the top animation.
I'm sure you'll finish up in a few minutes, right?
That's right, Philip. Yes. 3 more slides. I'll jump through them. As you can see in the upper animation, even under strong mitigation, we will still see further warming in Southern Africa, but we can restrict that warming to between 3 and 4 degrees Celsius by the end of the century. Okay, I need to conclude that Philip has made that quite clear. I will show only this slide and the conclusions. In brown shades there, you can see for different times into the future, the Southern African region is projected to become generally drier in a changing climate. Colleagues, this is really, really important. Our region, Southern Africa, is naturally a warm and dry region. Now, under climate change, it becomes warmer and drier. That greatly limits what we can do in terms of adaptation. So, very limited adaptation options for Southern Africa. Let me conclude. I'm only skipping 2 slides I wanted to show. Southern Africa is projected to become drastically drier into the future. This region is warming at about twice the global rate of warming. That is my first message. Even a successfully implemented Paris Agreement will imply challenges for Southern Africa in terms of future temperature increases, heat waves, and so forth. At the same time, the region is projected to see more frequent multi-year droughts. The Cape Town drought is one example. There is also a distinct possibility that South Africa's Gauteng province, which is where the economy of South Africa is centered at, may experience a day zero event because of droughts lasting for 3 to 5 years at an end. It's a major, major risk in terms of, just for a start, economic and socio-economic impact in South Africa. The IPCC special report concluded that under 3 degrees Celsius of global warming, which is about 6 degrees Celsius of regional warming in Southern Africa, the maize crop may well not be sustainable any longer. That's the staple food in Southern Africa. The cattle industry itself will also no longer be sustainable. Just imagine a Southern Africa without maize and without cattle. It is almost impossible to imagine such a Southern Africa. Yet, that is what the science is telling us. That's where we are heading. So we are making effectively, humanity is making our region less habitable. As I've pointed out in my talk, the least developed countries of the world are the most vulnerable to climate change, but they have not really caused this problem. Where is the justice in this? Then there's now evidence that we are on the verge of destabilizing Greenland and West Antarctica. That will impact not only on ourselves in terms of sea level rise, but more importantly on future generations. If those 2 ice sheets melt away, we are committing the world to about 12 to 13 meters of sea level rise. Our generation will not have a good name. a century or three into the future at the rate we are currently hurting the environment. Finally, it is still possible to slow down global warming. We can still minimize impact in our own lifetimes. At least we can slow down the rate at which dangerous impacts are happening. And with a concerted effort, we may still prevent these most dangerous impacts of climate change. So there is still hope, but it requires a tremendous effort and collaboration from all the world's main economies. Philip, I'm sure you'd like me to stop at this point, and I hope there's time for some good reflection on this. Thank you.
Thank you very much. Thank you very much, Francois, for this comprehensive and concise overview. Greatly appreciated. The one thing that we are missing in this kind of webinar sessions in comparison with the physical meetings is that the round of applause is somewhat difficult.
Thank you.
I see people clapping their hands. We cannot hear them.
Thank you, everybody.
Thank you very much. Greatly appreciated. It's really an exciting presentation. Thank you very much.